Today we are talking about how real engineering teams are using AI for coding, and we will cover 4 things. First, how many companies are actually hiring more engineers, especially good companies. Then, how AI works with large code bases, which remains the #1 challenge for teams. And then we will dive into a philosophical but also practical divide with AI tools about autonomous versus augmentation tools, or as I like to call them, robots versus Iron Man. And finally, we will see how the best teams are actually coding with AI and how they optimize for developer happiness by giving AI all the bad stuff and keeping the good stuff human. So let's dive in. And if you're new here, my name is Luca. I'm a startup founder and CTO turned content creator. I run a newsletter for 150,000 engineers and managers, which you can find at refactoring.fm. And of course, I run this YouTube channel. So over the past few months, there has been an explosion of AI tools for coding. I have an ever-growing list of things to try. There's Lovable, Windsurf, Bolt, ReZero, and more. So the FOMO is real and I'm not immune. And as models become more capable, the future of software engineering looks completely tied to the future of AI. Yet there is this growing divide that I find hard to explain. On one side, there are people building incredible things just by vibe coding, like Peter Levels with his latest flight sim. On the other side, there are real engineering teams I speak with who are, let's say, meh. They report decent but not extraordinary gains. So why is that? I believe it's because of 2 reasons. The first one is the difference between greenfield and big code bases. And most tools out there are optimized for greenfield development. And so are most of the examples you can find. While real teams with big, seasoned code bases can't do much with many of these tools, like Lovable for example. And the second reason is the single versus multiplayer experience. AI workflows are still largely single player, and they kind of break when working in a team. Harper Reed reported it in this awesome article which I'm attaching to the video, and I'm quoting him here. He said, "My main complaint about these workflows is that the interfaces are all single player mode. I've spent years coding by myself, years coding as a pair, and years coding in a team. And it is always better with people. And these workflows are not easy to use as a team. The bots collide, the merges are horrific, and the context complicated. I really want someone to solve this problem in a way that makes coding with an LLM a multiplayer game, not a solo hacker experience. There is so much opportunity to fix this and make it amazing." So the team angle is the most interesting one to me, and that's what we are diving into this week. And we will start with some market pulse, because how has AI changed the job market so far? And the surprising reality is that good companies are actually hiring more engineers. How is that possible? The reason is that in most markets, the demand for software is elastic. That is, if the price per unit of output drops, the demand grows by at least the same amount. So you can visualize this in a simple thought experiment. If your team could magically produce 3 times the amount of software as today, how would you use that power? Would you reduce your team, or would you keep it as is to grow faster? For companies that are profitable and or hungry for growth, the right answer is obviously the latter. So last week I spoke with the folks at Augment, who work with thousands of engineering teams, and they report that many are hiring more engineers because of AI. Which is the famous Jevons paradox. In some areas, the demand for software is highly elastic, which means it grows more than linearly in response to price decrease. So I believe the response to AI will depend on the type of organization you're in. Top teams that make the most out of engineers, where teams ship fast, often, and with little overhead, will hire more engineers because of AI productivity. While average teams, where engineers create value but are constrained by bureaucracy and the cost of coordination, will simply stay put. And finally, pure teams, where tech is a commodity and value is capped, will shrink in size to optimize costs. So this is the future, but where are we today, and what do we need to make this happen? Now, today's models are already performing like top software engineers in pure algorithmic problems. Already last October, Claude 3.5 was able to autonomously solve 86% of a random set of LeetCode problems from all ranges of difficulty. However, when faced with real freelancing tasks, this percentage drops to 26%. You can check out a recent OpenAI benchmark which I'm attaching to the video. Now, this difference is all about context. As a senior software engineer from OpenAI noted, AI can generate code snippets well, but when it comes to fitting them into an existing project, it often fails due to lack of context. Also, these benchmarks are about the previous generation of LLMs. The recent releases of Sonnet 3.7 and GPT 4.5 will surely move the intelligence bar higher, making context an even more obvious bottleneck. So when it comes to coding, how is context passed to AI? There are three possible ways: fine-tuning, context window, and RAG. Out of these, only RAG is showing promise. Fine-tuning is unpredictable, slow, and extremely costly, while adding code to the context window doesn't work at scale. It doesn't seem to guarantee precision. So good RAG is the best candidate to scale AI coding tools, but we are still early days and RAG architectures are not a commodity. We are still learning how to build them well and for different types of content. For example, code is completely different from, let's say, literature, and for different use cases. So I guess we'll see. But let's say models are smart enough and context is somehow solved. How are human engineers going to work with AI? Now, with the current generation of tools, we are witnessing a big divide that is just as practical as it is philosophical. It's about autonomous tools versus augmentation tools, or if you prefer, robots versus Iron Man. Autonomous tools are tools that behave like independent agents, whose goal is to approximate a coworker. Think about Devin or Lindy. While augmentation tools are tools that give humans superpowers, but where ownership of work is still ultimately human. In software is tools like Augment or Cursor. So what does it change on a practical level? Actually, quite a lot, because autonomous tools own work. You may ask them things on Slack and they submit PRs by themselves. But augmentation tools instead are aids to humans. You interact with them, for example in your IDE, and the PR is submitted by the human author. So what is the right strategy? Well, this is not a black or white call, as I expect the two to blend over time, but there are fundamental differences. The first one is about feedback loop. Augmentation tools have a tighter human feedback loop because the batches of autonomous work are smaller. So until we are really in the end game of AI engineers, letting AI run autonomously and submit PRs is probably not the most effective way to work with it, because you want to intercept errors earlier and iterate faster. And the second factor is scaling. While augmenting humans doesn't pose further organizational challenges, using autonomous agents kind of does, because how do you orchestrate work? Do you focus individual agents on specific tasks? And will you need at some point to employ manager agents to oversee a team of IC agents? That's what Devin is saying. And finally, there is a very human angle that is about empowerment. I believe in tools that empower humans as opposed to replacing them. And while we are still far from this in either case, I believe it's important to point the ship in the right direction and provide the right vision from the start. So in short, I root for AI to help us create the Avengers rather than the Clone Wars. And so if the goal is to empower humans, how do you do that? And how are successful teams doing it already? It seems that the number one rule for creating good AI workflows is not to maximize developer productivity, is to maximize developer happiness. That is, use AI to reduce toil instead of increasing it, as a share of the total work that a developer has to do. This is non-obvious, mind you, because many workflows you can find online corner humans into mostly fixing AI's bugs, which is never going to work, because if all that people are left to do is scrap, they are going to hate their work and quit. So the question is the opposite. What toil can we give AI? And here there are some solid emergent answers. And the first one is testing. In a surprising turn of events, test-driven development is having a silent renaissance thanks to AI. If you ask me, TDD has always been an obviously good workflow, only hard to put in practice because people on one side hate to write extensive tests and on the other side hate to think too much beforehand. So for many developers and many teams that already have their own share of troubles, that's too much cognitive load to ask for. But AI is changing this by addressing both issues at their core. Because at once, AI is very good at writing tests by removing all the boilerplating load from humans. And also, AI usually rewards those who think more beforehand. In fact, teams that are getting the best results are those that create good specs and plans and let AI implement them. And at this point, TDD becomes trivial, because if you need to write good specs anyway, and testing becomes almost free, you might just as well have AI create a testing plan first. So add that to the AGI conversation, because if AI finally convinces us to write tests, it might really be smarter than us. And the second domain where it is changing everything is documentation. For many developers, writing docs is the ultimate evil, possibly even more despised than testing or fixing bugs. Good docs are hard to write, hard to organize, and hard to maintain. So just like with testing, AI is attacking this problem from all angles. Because first, AI writes and maintains high-quality docs effortlessly, from inline comments to full design docs. Then it is also able to fetch them from pretty much wherever they are, reducing the need for perfect organization. And finally, to add insult to injury, AI is able to explain code well even without docs. Now, this final quality is dangerous because it can make people think we don't need docs anymore. But we do, because AI can look at some code and explain what it does, but not why it does things that way, nor the context that led our decisions about it. So I expect AI and humans to collaborate on docs in different ways based on the type of information. So low-level docs, like code comments and text specs, may become largely AI-generated, while high-level artifacts like engineering principles, design docs, and ADRs will stay human-driven. And finally, let's talk about quality. And I know, I hear you saying quality is not toil, and it's true, but well, quality is the result of 1,000 things, some of which are kind of toil. Think about does code match your standards or conventions? Or are there any smells or obvious improvements? Or are there any security vulnerabilities? Now, when integrated right, AI is good at spotting many of these, which means you are raising the bar for the software quality you produce, while also reducing the cognitive load for your developers. It's still early days for tools that help with all of this, but I'm already a fan of Augment, plus more targeted ones like PackMind and Codacy. Finally, a question that I get asked a lot. Should AI-generated code be tracked and monitored like teams do, for example, with their open source dependencies? And my answer kind of goes back to the autonomous versus augmentation tools. If AI does some things completely on its own, then of course you need to track how it fares against regular human output. But as long as AI augments human work, how can you really separate AI code from human code? And also, what's the point? So to evaluate the impact of AI, my suggestion is just to focus on overall productivity and developer satisfaction. Are developers happy with the tools? Do they want to keep using them? Are you able to ship faster? So that's it for today. Let's do a quick recap of what we learned. First, that companies are hiring more engineers and not fewer. Top organizations are experiencing Jevons paradox. As AI makes development more efficient, they're expanding their engineering teams to creating even more software. Second, AI workflows need to become multiplayer. The current AI coding tools are optimized for single developers working on greenfield projects, while real teams need collaborative AI experiences that work across shared code bases. Third, Large code bases remain the frontier challenge. While AI excels at algorithmic problems, it struggles with real-world tasks in existing code bases because of context limitations. 4. Augmentation beats autonomy. I believe that tools that empower humans create tighter feedback loops and better results than fully autonomous coding agents that try to replace engineers. 5. Optimize for developer happiness, not just productivity, because successful teams use AI to reduce toil rather than increase it, focusing on making engineers' work more fulfilling. 6. TDD is having a renaissance. AI excels at writing tests and rewards teams who create good specs up front, making test-driven development more feasible and less burdensome. 7. Documentation is getting an AI makeover. AI is transforming docs by writing code comments and tech specs, while humans focus on higher-level documents and architectural decisions. 8. Quality becomes easier, because AI helps enforce code standards, identifies smells, and catches security stuff, raising the quality bar while reducing developers' cognitive load. And finally, tracking AI code is kind of an anti-pattern. When AI augments human work rather than replacing it, separating AI code from human code becomes counterproductive. Just focus on overall productivity and satisfaction. So that's it. I wish you a great week, and as always, thank you for watching. Thank you so much for listening. If you found this chat valuable, you can subscribe to the show on YouTube, Apple Podcasts, Spotify, or your favorite podcast app. Also, please consider giving us a rating or leaving a review, as that really helps other listeners find the show. You can find all past episodes and learn more about the show at refactoring.fm. See you in the next episode.